Welcome students. Today in this lecture we will discuss about the pure rolling motion. But before discussing about pure rolling motion, we will discuss about some basic needed to understand this topic. So let's firstly list out the points to be discussed in the lecture. So first we will discuss about the rigid body, and then kinematics, and then at last we will discuss about the concept of pure rolling motion. So first question is, what is rigid body? So let's suppose we have any arbitrary shaped body, and this is 2 points A and B. There are 2 points on this body, and if I apply external force on this body, and then if the separation between these 2 points will change, then this body is known as non-rigid body. But if the separation will remain same, then this body is known as rigid body. So for rigid body, separation between any 2 points, any 2 points remains same. We can understand it by taking an example. Let's suppose we have two bodies. First one, let's suppose we have an football, or we can say basketball, and okay. So first we have a, let's suppose we have a ball, and other body is let's suppose a stone. This is stone, and if I apply force, if I apply force on this ball, then what will happen? Is the separation between these 2 points is same or change? Of coursely change. So let's suppose after applying force, the body looks like this. These are the points A and B. So separation between the 2 points will change. So this body is non-rigid body. And now if I apply force on this stone, then separation between 2 points, if I consider 2 points here, let's suppose A and B, then separation between 2 points will remain same. This is A, this is B. So this body is our rigid body. Rigid body. Okay. Now let us discuss about the motions of rigid body. So rigid body is basically performs three types of motion. So the first motion is translation motion. Second one is rotation motion. And third one is translation plus rotation. It is also known as rolling motion. motion. So let us discuss about the translation motion. So if we have any arbitrary body, let's suppose the point A and point B on this body, and this is the situation at, let's suppose, t equals to 0 time. And if I talk about any arbitrary time, so this is point A and this is point B, and this is the situation at t equals to t naught. If this body is performing pure translation motion, then the line AB, if I name the point this A dash B dash, then line AB is parallel to A dash B dash. This is the basic property for the translation motion. And now let's talk about the rotation motion. So in a rotation, let's suppose this is the situation at t equals to 0, and this is the situation at t equals to t naught. So if here the AB is not parallel to A dash B dash, so in this case AB is not parallel to A dash B dash. And now third part is translation. If any arbitrary body performing rolling motion, or we can say translation plus rotation motion, then that means if this is the condition, let's suppose this point A and this point B, and this is the situation at t equals to 0. If this is performing translation plus rotation, then after t equals to t naught time, the body is looks something like this. That means it is rotating, also doing translation motion. Let us understand by taking this duster. Let's suppose this is an arbitrary body, and let's suppose these are 2 points on this body. If this body is performing translation motion, then this will move like this. Okay, so the points are parallel. Okay, and if this body is performing pure rotation motion, then this body will move like this. That means it is rotate about its axis like this. Okay, and now if it is performing the rolling motion, then it will move and also it will rotate. So its motion is like this. It is rotate and also translate. Okay, so this is about some basics of rigid body. So till now we discuss about rigid body, and we discuss about the kinematics, or we can say motions of rigid body. In this lecture, our main aim is to understand about the concept of pure rolling. So we will focus about the rolling motion. So let's proceed. Okay, so our topic is pure rolling. So let's suppose, have you ever seen a car? Let's suppose this is a tire of a car. If I assuming this is a rigid body, then what will happen? The center of mass of this rigid body will move with velocity v in forward direction. Also, it is rotating with angular omega. It is rotating with omega angular velocity. So if I want to know the motion of every point on this body, so we can easily find out. Okay, so let's suppose I consider 4 points on this body. Let's suppose these points are A, B, C and D. So, and I want to find out the net velocity on these points. So first we have to find out that what velocity these points have. So first, because of its center of mass motion, we discuss if any rigid body have any point have velocity v, then every point of this velocity have v in the same direction. So every point of this body will move with velocity v in forward direction. And also it is rotating about angular velocity omega, and we know if any body is performing a rotation motion, then every point on its circumference have a certain velocity, that is tangential velocity, and that is equals to r omega, and it is tangent to every point. So if I talk about this point, then this point have velocity r omega in this direction, and it is rotating like in this way, like in S for like this clockwise. So this point tries to move in downward direction with r omega, and this point try to move in backward direction with r omega, and this point try to move in upward direction with r omega. Now if I want to find out net velocity, our target is, okay, so v net velocity at A we can write down as v plus r omega, because both are in same direction, so we can directly add them. Now at this point both the velocities are perpendicular, so we have to take resultant velocity, and that is equals to v square plus r omega whole square. And at this point the net velocity at point C equals to v minus r omega, and at this point again both the velocities are perpendicular, so we have to again find out the resultant velocity, and that is equal to this within magnitude. Direction will be different but magnitude will be same. Now our main concept is pure rolling, so let us discuss about this point of contact. Okay, so let us discuss about this point of contact. Here is three cases are possible. First one, v greater than r omega. Second one, v less than r omega. And third one, v equals to r omega. So if I consider first case, v greater than r omega, then what will happen? Then if v is greater than r omega, that means its translation velocity is greater than its rotation velocity. Okay, that means there is a relative motion between surface and point of contact. Then this point of contact tries to move in forward direction, that is known as forward slipping. Forward slipping. Now if I talk about v less than r omega, that means v is less than r omega, that means this point tries to move in backward direction, and this is known as backward slipping. Backward slipping. Now if v equals to r omega, that means v equals to r omega, that means this point of contact, the relative motion of this point of contact is 0, then what will happen? That this motion is known as pure rolling, and this is the concept of pure rolling when this platform at rest. So for pure rolling, V equals to R omega, and from here omega equals to V by R. So this is the concept of pure rolling, or we can write down the definition for pure rolling, that relative motion of point of contact is 0. Okay, 0, or we can say there is no relative motion of point of contact, then the body is known as in pure rolling motion. Now this is the condition where the platform velocity is 0. Then what will happen if platform will move with some certain velocity v0 in this direction? So if platform is moving, then this point should have to move in this direction to become relative motion 0. So in this situation, point C will also move with velocity v0 in this direction. So in this case, V minus R omega is not equals to 0, it is equals to v0. From here, omega equals to V minus v0 upon R. This is the condition of pure rolling when the platform is moving with some velocity. Now let's do a question. Now let's suppose the question is, this is a rough surface with the friction coefficient mu, and this body is performing translation motion with velocity v0, and we have to find the time at which this body starts pure rolling motion. So let's discuss. So if this body is moving with velocity v0 in forward direction, then this point also have velocity v0 in forward direction. That means there is a relative motion. If there is a relative motion, then what will happen? This point of contact should try to move in forward direction. So here surface is not smooth, then friction force will act in this direction, and this friction force will equals to mu n, and here normal force will balance by its mass mg. Let's suppose this is a sphere, solid sphere, then this is equals to mu n, then we can write down friction equals to mu m g. Okay, now this is the equation for friction force. If let's write down the equation first for the translation motion. Here who is providing it translation motion? No, there is no force, but this force is providing it a retardation. That means this force, this friction force, reducing its linear velocity. So we can write down that friction force equals to minus m a, because it is reducing its velocity. Okay, so from where we can say that acceleration equals to minus a by m, and also this friction force providing it torque in clockwise direction, that increase its angular velocity omega. See here, initially there is no angular velocity, and after some time there is some omega angular velocity, because this friction force provided a torque. And so let's write down the equation for torque. So friction force F and torque equals to R cross F, and here R is in this direction perpendicular to this, and this is, so R and F are perpendicular, so we can write down directly Fr equals to, we know torque equals to I alpha, where I is the moment of inertia of this sphere. So F r equals to I, we can write down 2 by 5 m r square alpha, because moment of inertia for a solid sphere is 2 by 5 m r square. One r is cancelled out from here, so alpha from here we can write down 5 f upon 2 m r. So we have alpha and we have a, both type of acceleration we have. So now we have to find out the velocity at time t, because the velocity will reduce and also omega angular velocity will increase. So we have to find out both the velocities. So from the Newton's equation we know v equals to u plus at, and initially velocity is v naught. So v at time t, let's suppose this is the time where the body starts pure rolling motion. So this is initial velocity v naught, and acceleration is minus f by m t. This is our first equation, and if I write down the equation for its rotation motion, then we know omega equals to omega naught plus alpha t. Then omega equals to omega naught is 0, because initially it is no rotation performing not rotation motion. So plus alpha is here 5f divided by 2 mr, and this is t. Now what we have learned, we learned that if body is performing pure rolling motion, then v equals to r omega. That means let's put out the values from equation 1 and 2. V equals to v naught minus f by m, t equals to, multiply it by r and put it. So f 5f upon 2 m t. From here v naught equals to, take this term here, 5f upon 2m t plus f by m t. From here v naught equals to, here is also a t will common, and here 5f by 2 m and f by m. Okay, so we can write down, I am erasing it. So t here it is 7f by 2m and equals to v naught, and from here t equals to 2m v naught upon 7f. So this is the time when body starts pure rolling motion. So that's all for this lecture. Thank you.